Hey guys, BuildZoid here, and today we're going to be doing some really, sort of the very first Volt mod you need to know before you do any other Volt mods, because, we're going to be attaching voltage sense lines to a motherboard here. So actually I'll point you down to this because, yeah, there we go. So, yeah, that's the Asrock X370 Taichi motherboard. Physically, it's by far one of the best motherboards that, you can get on AM4. Now, the thing is, I'm not a fan of trusting software readings because some motherboards, they work great. Some motherboards, they work absolutely awful and they read garbage. So what we're going to be doing here is we're going to be attaching a physical wire to the back of the CPU socket so that we can get really accurate Vcore readings on my digital multimeter here. So basically the reason why you want this is you can then compare voltage settings from motherboard to motherboard, and you know for a fact that they're the same because they've been measured with the same tool. Because some of the motherboards, they might read a little bit off. Generally, CPU voltages are actually really well recorded, like really well monitored, but like memory voltages are all over the place. Like the Apex motherboard from Asus, the memory voltage reading on that board is off by something like, I think it's like 35 millivolts off. And there's other motherboards where it's even worse, and they're off. On the Apex reads 35 millivolts too high or something. I've heard of motherboards where they read like 50 or 100 millivolts too low. Yeah, but that's on the memory VRM, which generally isn't as important. So, these huge voltage errors aren't like a catastrophe there. Vcore VRMs are generally a lot more accurate, but I still don't trust them because, it's just better to know for sure that it isn't just some weird sensor misreporting or something. It's better to know for sure that it is, in fact, the same thing. Now, unfortunately, you can't read voltages off of, say, if I put it this way, you can't read Vcore voltage off of this capacitor bank right here, because that's right after the output of the VRM. And your big problem is that this distance right here from the VRM to the CPU socket, and then through the socket, that has some electrical resistance. And depending on how good your motherboard is, that resistance will be low or really high. So the Taichi is a pretty good a good example, like a high-end board. So we have a lot of so we have more PCB layers. I'm not actually sure how many this has. And you'll have, like Gigabyte has this whole marketing thing for their ultra durable series motherboards where it's like 2-ounce copper layers. And the reason why that's not a complete gimmick is because extra copper actually means that they get less V-droop from the VRM to the actual CPU. Because basically, if you're pushing 100 amps, even over this small distance, if there's, say, a milliohm of electrical resistance, that's 100 millivolts of voltage droop from the Vcore VRM to the CPU socket. And that, 1 milliohm of resistance, that's resistance both from the low side MOSFETs, the actual copper going from the VRM to the CPU, and just all of that adds in and basically gives you your voltage droop. So you can't measure voltage off of the VRM because if you have LLC enabled, what the VRM actually sees, like the voltage controller, reads the voltage as close to the CPU as possible. In fact, there's a pin on CPU sockets which is used by voltage controllers to read CPU voltage basically off of the CPU package itself, which would be ideal. Unfortunately, for Ryzen, that would mean delidding the CPU and then trying to solder onto the capacitors around the CPU, which would suck. That would be incredibly hard to do, and, very high probability of you killing the CPU. So the next best thing you can do is measure voltage right off of the back of the CPU socket, which is generally a lot better. If we just talk about a motherboard that I've already modified like this, which there's a bunch of things I've modded like this, but say the Asus B350 Plus motherboard, the really budget one, I've modified that one, and if you measure Vcore right off of the output of the Vcore VRM, you're going to be reading about 1.52 volts, By the time that 1.52 volts gets to your CPU, it turns into 1.4. Well, actually, like 1.395 volts, and that's just running Cinebench 11, so 11.5. So you get a massive amount of V-droop on some motherboards just going from the Vcore VRM to the CPU socket. Same goes for the actual SoC VRM. You also get V-droop on that as well, except the current going through the SoC VRM is a lot lower, so the V-droop won't be as big. So yeah, so today we're just going to add a voltage sense line so you can actually get accurate physical readings and not, you know, garbage that you get if you measure right off of the Vcore VRM. So yeah, let's flip this over and look into the, and actually I'll move the camera because we will be doing close-ups here. Hopefully, and I'll actually have to manually focus this because autofocus on the webcam, of course, sucks. Somebody's probably going to go into the comments and say, Buildzoid, buy a better camera. If I buy a better camera, I can't buy as many motherboards now, can I? There we go. Try. Yeah. Also, the desk will shake a lot because it's an IKEA desk and it's cheap. And it's actually, I think I basically went for the cheapest IKEA desk that I could find, so yeah. Let's try to get this in focus. And my monitors are like a mile away. Oh, this is going to be a pain. That didn't focus enough for you? I'm going to call that in focus. The monitor is a, like, good 2 meters away and not exactly massive, so I can't see I myself can't really see how in focus this is. And let's try to get the multimeter in there. Actually, I'll still need to tilt that, won't I? Let's see. Get something under it. There. It should give it enough angle. So multimeter into resistance mode, and you can't see anything. Oh, if I tilt it that way, that'll work. Great. So we'll work with that. And the first thing we need to do is identify Vcore. Now, we already know where the Vcore VRM on this motherboard is. It's basically, you have these doublers right here. Actually, no, these are doublers. Well, doubler driver chips, so yeah. I think these are 3590s, 3598s. Yeah, these are 3598s from International Rectifier. Those are, you have one PWM signal in, and then two drive systems going out of one of those. So yeah, and these four right here are Vcore, these two up here are also Vcore, and then this right here is the SoC VRM, which is a doubled up 2-phase into 4-phase, and the Vcore VRM is doubled up 6 into 12. So yeah, but we don't actually care about these. What we care about is the capacitor bank in front of them. On some motherboards, you'll actually have the inductor, like some motherboards have through-hole inductors, in which case you can just use the inductors, which are much easier to work, in my opinion, easier to work with. But here we're just going to use the capacitors. Now, I really recommend, if you're doing this kind of thing on a motherboard, do it without the CPU installed. It's way, way easier to get good measurements. If you're working on a GPU, you kind of have to put up with the fact that GPU cores have very low resistances. And it's getting worse as the manufacturing processes get smaller. 16 nanometer TSMC GPUs actually read under 0.5 ohms, which, say, for this multimeter is, like, I can't read that. I literally cannot measure under under 500 milliohms because this thing's just too inaccurate for that. So on, like, new high-end NVIDIA GPUs, you're kind of screwed. On older GPUs, a lot of older GPUs will hover around like a 1 ohm, and if they're low end, or depending on the die size, the electrical resistance when they're turned off actually goes up and up and up. So you'll have like an HD 7990 is, no, the 7970 is like 2.5 ohms electrical resistance when turned off, whereas a Fury X is like 1.7 or 1.5. It's a lot lower. Either way, let's get this motherboard. Motherboards will vary. Some of them will be in the kilo ohms. Most of this one right here is only in the hundreds. Let's just read across one of these capacitor legs. Try to get the angle better for you. There we go. Just read like that. And we can see that it's reading, wait, get it steady. And it's about 90 ohms, 91, climbing. Okay, there we go. 91.5, and now it's crapped out, and now it's 90 again. That's just because, you know, you're going to wiggle the probes and whatever. But basically, it's reading 90. So that, and this capacitor right here, which is also Vcore, will read the same thing. Obviously, they're in parallel, so just about 90. It was working its way up to it. But that doesn't tell us which side of the capacitor is Vcore. In order to figure out which side of the capacitor is Vcore, we're going to stick one probe against one of the legs, and then we're going to go and look for a known ground. And screw holes are all ground. The metal shielding of your I/O is also ground. So I'm actually going to take my measurement for ground off of the I/O, because I know that's ground, and it's an easy ground to find, and this is again at an awful angle. Actually, let's see. I could tilt the camera. Well, point the camera slightly different. There we go. So we're going to read off of this capacitor leg right here, and we're going to measure against one of these, because these are metal. These are the this is the metal casing of the I/O, right? So that's grounded, because that's just ground. We know it's ground. If you also want to check against a screw hole, you can do that as well. Those are also ground. So that's reading 85. So that's not ground, right? It's non-zero resistance. It's not ground. Then we check the other leg. This one is reading 0. So we know that this leg right here is ground, and this leg right here is Vcore. Great! So now we can move on to the actual socket, because we need to be able to, you know, orient ourselves around the entire motherboard where the Vcore power plane is. So now we know that one leg on that capacitor is Vcore, which is the one closer, the leg closer to the socket is Vcore on this motherboard. So we're going to put one probe against that leg. And again, if we go against a ground like here, then we can see that we have 90 ohms of resistance. So yeah, that is definitely Vcore, and I slid off of the pad there. Yeah, we have roughly 90, so that's definitely Vcore. Now we're going to move on to the capacitor bank on the back of the CPU socket, because we're going to be soldering onto these guys. So let's start with this one right here. Just pick any one at random. If it's 0, then like this one right here is 0, so this is definitely Vcore. How convenient for us. And if we move over to the one next to it, also 0. It's going to climb up a little bit. It's like 0.2. And this is exactly why I don't like new NVIDIA GPUs, because this multimeter fluctuates between like 0 and 0.3, 0.5-ish, depending on how you angle the probes and whatever. So, not great. But we can basically see that these are pretty much... Well, actually, I've already gone ahead and checked. So I actually know that all of these capacitors right here are 0. Like, these are all Vcore. Except for, and this is going to be hard to show you. Let's see if I can tilt the board enough. Yeah, it doesn't show up. But basically, these last 3 capacitors down here are slightly different size, slightly different spacing. Those aren't Vcore, and we can actually check that with the multimeter. So let's do that. So multimeter against one of those, again against my capacitor. And now we can see that we are not getting 0. In fact, we're getting like 165 ohms. That is not Vcore. I don't know what that is. I don't particularly care what that is. I just know it's not something I want to accidentally short this capacitor bank to any of these 3 capacitors over here. I really don't want to do that. So I don't want to solder onto these capacitors really near to that. We know all of these are the same, so we don't want to solder on the ones that aren't the same. So we're going to aim for sort of the middle. Now it's going to be a good idea to check the other capacitor bank right here, if that's also Vcore. There's going to be a lot of capacitors for Vcore, because Vcore is your main power plane. It suffers the most. You know, these capacitors are basically just Vcore to ground. These are bypass capacitors. These exist so that they clean up the switching noise from the CPU, because as it switches, it causes current fluctuations. Those naturally cause voltage fluctuations. The capacitors are there to soak up those voltage fluctuations and, yeah, basically remove them. And depending on what mix of capacitors and yeah, capacitor selection actually changes how well a board can overclock just because of the selection of capacitors back here. But anyway, let's check this guy. And we're also getting 0 ohms, which is nice. So yeah, now 0, 0, 0, 0, and 0. And I actually know that this entire second bank is also all Vcore. So basically, these guys right here, Vcore. Those guys right there, Vcore. These three at the bottom, not Vcore. If we solder to those, well, if we solder to those, we're gonna read some random garbage. I kind of suspect it's gonna be another voltage, because Vcore to ground is 90 ohms. So if this right here was ground, then it would read like 90. But it's not ground because it's reading like 163. And in fact, it's probably another voltage. But I don't really care what they are. The problem is if I short them out, then, you know, something's probably going to end up dying. It could be in the CPU. It could be the VRM that actually hooks up to those capacitors. It could be the capacitors. Like, yeah, you don't really want to do that. So we're just not going to solder near them. We're going to solder sort of in the middle of the Vcore. There's basically this row. From here to here, we have Vcore capacitors. And here to here, we have Vcore capacitors as well. They both have Vcore on the same side, so we're just going to solder right in the middle of them so that we can't accidentally hit something else. So, we've now chosen our target for soldering. Now we need to actually get around to the equipment. Now, here's something I like to do. If you are doing a voltage sense line, you can accidentally, like, if you have a voltage sense line, you know, you're going to usually do it in some kind of thin wire like this. This, I do believe, is 28 gauge American. And if you have this, and it's going from Vcore, and this wire, for whatever reason, ends up touching ground, this wire is probably going to get vaporized. And if it doesn't, because basically Vcore VRM, capable of tens to hundreds of amps, depending on what motherboard you're on. If this wire goes to ground, it's gonna pull that much current through it. And, well, actually the only limit on how much current is gonna go through the wire is the wire's own internal resistance, which is really, really low. And so that will cause major, major issues. So for that reason, I like to put a 5 kilo ohm resistor before I actually put my wire, because this 5 kilo ohm resistor, if I short the Vcore to ground from the sense line, then this 5 kilo ohm resistor is going to be limiting the amount of current going through, and it can't actually cause any harm. So that's why I like to put that's why I put a 5 kilo ohm resistor before any of my voltage sense lines, because it's basically a safety thing. So my soldering iron is up to temperature already. And so for today's job, I'm just going to be using a really big, monstrous tip. And it is set to 400 degrees centigrade right now. And the reason for that is, yeah, lead-free solder melts at like 220. Reflow and wave soldering is done at like 260 degrees. The problem is, this right here is a motherboard. It has a lot of copper in it. This is basically a giant heatsink. If you try to solder at like 300 degrees or something, you're going to have a very hard time getting anything to even wet. And I know that because that's how I've been trying to solder for ages and ages and ages. And I've had, like, my first Fury X capacitor mods were done with like 300 degrees soldering iron temperature. And basically what happened was all of the capacitors fell off because they never actually attached properly. What held them in place was basically just flux. Not actual solder, at all. So what ended up happening was they kept falling off. And basically, eventually I decided, okay, you know what? I read a soldering guide by Derp, and he said, you know what? Don't worry about cranking it up to 400. So I cranked it up to 400, and what do you know? Now my capacitors stopped falling off. Admittedly, my soldering is still really ugly, but at least things I attach stay in place. So I'll clean this off. I just use a heatsink for that. Now it's nice and shiny. Well, you can sort of see that, yeah, it's nice and shiny. So we'll just prepare our capacitor bank right there. Let's put some fresh solder on there, and I'm just going to pull in some. And I do use lead-free just because I have a ton of it available, so I might as well use it. And we're just going to go and gently, and there we go. Actually, yeah. Ta-da! And that's, yeah. I'm not worried about connecting to that right there. It's not a huge amount, but it'll work. And now let's just make sure that we haven't broken anything already. Let's check our resistance Vcore to ground. Still 90. Well, 90. You can't see it. So not particularly useful. But yeah, it is still 90. And you still can't see the... Can I get this closer? Oh, I can. So you can just about see it. So yeah, I have a little bit of... You can just about see that there's a little speck right there. That's where I put the solder so far. So now let's get my 5K, which I put where? There. Also, if you're choosing resistors, you can actually use higher resistances. You can use, yeah, 5K, 10K, anything in the thousands. If you go below 1,000, it, you know, you're gonna get more current. Just higher is sort of safer. It might skew your reading as well, but 5K works great for me, so that's what I'm gonna go with. So, yeah, and we're gonna trim this off before we attach it, obviously. I'm thinking I'm gonna attach it like that. Yeah, that seems like a good idea. And then I'm gonna, yeah, okay. So, oops, how did that stick to my hand? Interesting. I'll just put that down there. Let's trim this off. Because, there we go. I want it like that. And I think I'm going to go for that much. Yeah, that's enough. Right, so now we'll take something to hold this, because if the iron's at 400 degrees, the motherboard might have a lot of thermal capacity. This doesn't. So if I try to hold this while soldering it at 400 degrees, it's going to burn me. And my hair's in the way. That would smell bad. And we just need to get it like that. So I'm going to tin the capacitor first, and I'm just going to do that above some spare PCB down here. Do not tin above any important anything, because if your solder drips down and manages to actually make a connection, you're going to have a bad day if you miss it. So, yeah. That's another tip. Up. Ta-da! And that'll do. And you can't actually see anything, because again, it's not in focus, but yeah. Oh well, this is the best I can do right now. And let's get that in place. I'm going to try... Go. Yep. Yeah, okay, so that's in place. It's kind of sticking off a bit far. We'll see if I can get that. That fell over. Yeah, I need to tweak it a little. There we go. I think I'm going to leave it at that point, because generally the more times I try to rework something, it gets worse. Nope, that got taller. Want that tall. Okay, let's just leave it like that. It's not great, but it's something. It's attached, and we don't have a short circuit, then I'm going to call it a win. Do we have a short circuit? Let's check again. We can just check off of these capacitors up here. Don't need to use the low ones. And we're still at 85, so that's good. 90, so that's great. We're not shorted out. So now let's check against the end of our resistor, and it should just read 5.6K, because this is a 5.6K. And it reads 5.5, because, you know, there's manufacturing tolerances involved on pretty much everything. So now we have our resistor in place, and at this point it's just a case of adding a wire. So I'm gonna, you know, whatever length you want works. Wire length really isn't gonna affect this. If you know, might want to mount the wire somewhere on the motherboard or something, but go for whatever length. And I've gone for roughly 30 centimeters because really, that goes way past the board. And we're also going to trim off the excess on the resistor at this point, because naturally I don't want this hanging off. And incidentally, a lot of AM4 boards have like open socket cutouts, right, for the capacitor bank. Asrock does not have that on this board. What you get with this board is this. So yeah, this is a pain, but you don't have to use the socket cutout, so whatever. If you're using a liquid nitrogen pot mount, which has typically they have solid flat plates, yeah, this tends to cause some issues. I do plasti dip everything just for electrical insulation and as well from water. But yeah, you're gonna need to get some kind of spacers or padding in place for for resistors like this. There we go. That's trimmed to a length I like. Fortunately, the leg of that resistor fell into the memory area, but that will fall out once we flip the board over, so I'm not going to bother with that right now. So you can see it right there. So I'll tin the end of that resistor again, just to make sure that when I come in with the wire, don't have problems. That's tinned now. And let's get our wire, and we're going to strip this, tin it on both ends, and then we're just going to attach it. How you decide to terminate your wire, you can end it with a crocodile clip or whatever else you want, because again, you have this resistor here. It could literally just be a bit of bare wire, and because of this resistor, even if you leave the ending of the wire completely bare and you touch it to ground or something, you're still perfectly safe because of that 5K. So yeah. Now, if you're doing if you're running like a liquid nitrogen or something, and your base plate can't let you fit a resistor in place, then yeah, you might want to just go with straight wire to the capacitor bank, but that doesn't really change that much. And then you have to be a lot more careful with where you leave that wire. I've actually had that happen on, I think, my GT710, where I had a wire that went from, I think, straight from Vcore to ground. And that, well, it smelled really bad. It didn't really cause any major issues, it just smelled bad, so let's get that tinned up. That's nice and shiny now. You can see it's all silver instead of copper. So that's tinned well. We can do the other end as well. Honestly, at this point, this is just soldering 101. Up. Came right off. And actually, let's do the approach. So I'm going to twirl these up. So I like to terminate my wires with screw terminals because, they're cheap and plentiful, and you can stick you can stick the probe of a multimeter into the screw terminal really, really easily. So that's why I like to terminate with those, but yeah, whatever you want, you can use. And whichever one is shorter, I will actually end up attaching. That's a bit long, but hey, whatever. Ta-da! And that's way too much solder on there. And actually, for this part, you might want to lower your temperature. I'm still going to do it with 400 just because. There we go. Yeah. So what was happening there was, because I'm soldering at 400, the solder, because the resistor actually, blocks some of the thermal conductivity to the motherboard. So what would happen was that solder actually stayed liquid after I pulled the tip away, which just means you have to not pull on the wire. You have to be patient and leave it there for a bit for the solder to solidify. Otherwise, yeah, it's going to disconnect. But yeah, that's pretty much it. It's really not that difficult, but it is an important mod to do on anything you want to get good accurate voltage readings on. I've done it on the Prime motherboard the Prime B350 Plus board, because I want to run that motherboard on liquid nitrogen, so I need to be able to read right off the back of the socket, because I need to know what voltage it's running. But yeah, and I've done it on the Taichi because I really want to be able to compare the Prime, the Plus, to the Taichi. Because the Taichi, I've managed to run 4 gigahertz on this board at around, 1.42 or 1.45 volts in the BIOS with the level 5 LLC, right? Whereas on the Prime, I need to run 1.4 volts in the BIOS with extreme LLC. And on the Prime, that translates to 1.394 volts on the back of the motherboard running Cinebench. So I really want to know if the Taichi is actually managing, like, does the Taichi's level 4 LLC match the, you know, level 4 LLC plus 1.45 volts match the Prime's voltage under load, or is the Taichi just a better VRM and the voltage is actually drooping well below 1.4 volts and the Taichi is just still maintaining that 4 gigahertz overclock? Because this board has a this board has a 12-phase VRM, the plus is a 4-phase, so this should run cleaner power, and this is really the only good way to test that, other than, you know, hooking up an oscilloscope to the VRM, but with the oscilloscope I have, that doesn't tend to go very well, so, yeah. So, that's it for this video. Let's get the camera back up, and let me fix that. Actually, I forgot one crucial step at this point. I forgot to check if all of my resistances are still good. But, you know, this is how you do volt modding, and my hair fell down. For those of you new to the channel, the whole crazy hair thing is intentional. It's not something that, you know, I forget to... Yeah, there we go. Standing up again. So, yeah, that's how the, that's how you basically attach a voltage sense line. You might want to cover that in, like, well, I always plasti-dip all of my connections, liquid electrical tape, which is basically just plasti-dip again, but under a different name. Well, plasti-dip is liquid rubber, whereas liquid electrical tape I've never used. I don't know what it is. I haven't looked into it. Well, yeah, that's how you can get really accurate voltage readings on motherboards, and also that 5K ohm prevents you from blowing yourself, well, blowing up the wire. Not really blowing up the board. The board will handle it, and really everything else will handle it, but the wire won't. So yeah, that's it. You know, this whole volt modding thing, I'd love to hear your feedback on this down in the comment section. Like, it really matters to me, because this type of video, I've been putting these all, like, basically, I've wanted to do volt modding videos for, like, ages and ages and ages, but the problem is, I can't figure out how to do them. So I want to know, was this incredibly boring? Was this too long? Do my soldering skills suck? Yes, they do, I know, I'm fully aware. You don't need to tell me about that. Could you see what I was working on? That's the really concerning thing for me, because this is really small stuff, right? And if you can't see it, then there's no point in me doing it, because I could just as well write up a guide where I point to solder here, solder there, solder this, cut that, cut this, cut, you know, do this, that, and this, and it would work out just as well in terms of the amount of use you would get out of it. So I really want your feedback on this video, because, you know, I want to do these, but in the past, they've just basically been a video of watching my hands move around above a PCB, and nobody had any idea what was actually going on. So, yeah, that's a thing. And with that, let's end this video, because it's already way too long. Thanks for watching. Like, share, subscribe. If you've already subscribed, there's also the notifications thing. You can do that. What else was there? And if you would like to support what I do here at Actually Hardcore Overclocking, I have a Patreon, I have shirts, I have a PayPal. You can find them all down in the description below. Actually, speaking of the PayPal, that's currently frozen. So don't try to use the PayPal, because I've already hit my PayPal, like, PayPal, there was a mess with my old PayPal account, so I have to redo, so I had to change accounts, and now this new account is again over the it's hit the limit for transactions again, so I need to sort that out. So right now the PayPal probably won't work, but the Patreon and shirts do. So yeah, that's it for this video. Thanks for watching, and see you next time.